Hey, this video is the first part of 3.4. We're going to talk about the average rate of change for functions. So a rate of change is really like the speed, how fast something is changing, right? Speed is a rate of change. We talked about slope being a rate of change in the past. And really, it's the slope idea that we're going to use for these functions. But think about, we're looking for an average rate of change. Just think for a minute about, say you go on a road trip and you're going to drive 100 miles, and maybe part of that time you're going to be able to drive 70 miles an hour. And maybe part of that time you'll even stop. Maybe you'll stop and take a break. It doesn't really matter what you're doing in the middle. So it doesn't matter what the function looks like, the distance function. It might be going fast, it might be going slow, it might be stopping, going, whatever. But really, all we're going to look at are the endpoints. We're going to say, well, we went 100 miles and we did it in 2 hours. That means we averaged 50 miles an hour. That's really exactly what we're looking at when we find the average rate of change with a function. So here's a function and we want to look at. And you might think of this as, the depth of the water in a pond, right? So maybe it starts out at 8 feet here. Maybe it dries up over the summer, and then when it rains and stuff again, we're back up here at 8 feet. If we were looking at 6, 7, 8, if we were looking at the average rate of change between 0 and 8, what's the average rate of change? So we're going from here to here. We don't really care what it does in the middle, but how did it change? Well, it didn't change. It was back exactly what it was. So the average rate of change here would just be 0. So we can have no change. We're just looking, we don't know what it does in the middle, and we just want to know at the endpoints that we choose. And the endpoints are going to be really important because it will be totally different with different endpoints. Okay? So let's start by looking at how we would find the average rate of change on here. Let's do between let's say 0 and 4. Okay, so here is if it were straight, we would call this a secant line. Okay, and we spell that S-E-C-A-N-T, right? Secant. And it's kind of like it's a piece of an arc, right? So it goes from one point to another point on the curve, and that line will tell us really what that rate of change was, right? So whatever it is here, well, let's just look at it this way. The y, we want the slope of this secant line because slope is a rate of change, right? So this point right here is 4, 0, right? And this point right here is 0, 8. So if I want to find the slope of that, I'll use this as my first one. We have the change in the y's, right? So 0 minus 8 over the change in the x's, so that would be 4 minus 0. So I have negative 8 over 4, or negative 2. So the average rate of change between 0 and 4. So did you catch that? We did it with the x's. We always talk about these functions in terms of the x's. So the average rate of change between 0 and 4 is -2. Okay? Now, let's look at it in a different place. So let's find the average rate of change between 2 and 8. Okay? So now we're going to find the slope of this line. So we want this point right here is 8, 8. This point right here is 2, 2. That's interesting. And the slope of this line, or the rate that this line changes, is 8 minus 2 over 8 minus 2, so that's 6 over 6, which is 1. Okay, so the average rate of change between 2 and 8 is 1. Notice that it was totally different, right? When we went from 0 to 4, we got this -2. When we go from 2 to 8, we get a +1. It'll be different no matter where we put the 2 points. So if we want to look at it in kind of a general terms, our average rate of change is going to be whichever point. So let's say we're going to go from x equals a to x equals b. So it doesn't really matter what a and b are as long as they're in the domain, right? And you remember that we chose the y values because that's how you find the slope. It's the change in the y's over the change in the x's, right? So the y values is the f of x values. So I want to find f of b minus f of a over, and then in the denominator is the change in the x's, so that would be b minus a. So this is the formula for the average rate of change. Let's just look at one more. We'll take the average rate of change between 6 and 8. Oh, maybe not. Okay, try it again. From 6 to, where's 8? Oh, click there. From 6 to 8, there's my secant line. It's looking actually very close to the curve, isn't it? So we look at our equation. We have f of b, so b's at 8. So f of b is 8. F of a, so here's my a, because that was the first one I chose, that's at 2. And b minus a, so that would be 8 minus 6. Alright, so I've got 6 over 2 or 3. So this average rate of change between 6 and 8 is 3. You can see that it changes every time, right? So we don't really need to have a graph to look at it, but you would know that, you know, basically the graph is what we're doing, whether we draw the graph or not, right? But always it's going to be the f of b minus f of a, that's the change in the y's, right, over b minus a. So in this case, this is a and this is b, right? So I want f at 8 minus f at 1 over 8 minus 1. Alright, well, f of 8, I plug 8 in here, and I have the square root of 8 plus 1, which is 9, minus, I plug the 1 in there. Man, I thought I was going to do one that worked out nice, but actually, we'll get square roots. That's okay. Over 7. Alright, so I've got 3 minus square root of 2 over 7. That's my average rate of change. Now, looks like kind of a weird number. If I plug that into a calculator, though, I could get a pretty nice estimate for it. That's my rate of change. So, sometimes we don't want to specify exact numbers because we just mean we want it from a certain point and just a little bit farther. And maybe we want to even change that little bit. So that's how we do it here. I'm going to go from x equals 1 to x equals 1 plus h. And I can kind of vary what h is. I can say, oh, it's going to be really low, or it's going to be really high, or whatever, okay? But it's just a little bit bigger. So it's a change. It doesn't matter what it is, it's a change, okay? So I still plug it in the very same way. I'm going to do g of 1 plus h minus g of 1 over 1 plus h minus 1. Okay, well, let's plug this in here. I've got square root of x squared, so that would be 1 plus h squared plus 2 minus, and I want to do the whole thing, right? So I plug in 1. 1 squared is 1 plus 2 is 3, so I'm going to minus 3 over. Now, look what happens here. I have a 1, and I have a negative 1. So that adds up to 0, and all I'm left on the bottom with is h. Okay, so now I want to simplify this. So remember, this whole thing is squared. So we're squaring a binomial. In other words, we're doing this, you know, this, if you want to call it FOIL. 1 times 1 is 1. 1 times h is h. H times 1 is h. H times h is h squared. And if I add this 2 and this negative 3 together, that's a negative 1. Okay. Now I have h squared plus 2h. And look, my 1 and my negative 1 is just 0. So that's divided by h. And I can actually factor an h out of everything. So now I'll just have an h plus 2. So that is my average rate of change. I don't know what h is, but had I chosen an h, and maybe it would even be, you know, a fraction or some really small amount, but that would be, I would just have to plug in what h was, and I would know what my average rate of change was. Okay, here's your quiz question for 3.4a. Find the average rate of change for this function, f of x equals 2 over x plus 1, between x equals 0 and x equals 3. Enter that answer into the quiz on Canvas. The next video is going to go continue on with average rate of change. So we'll be doing more on this subject.